Howdy. So, this last part, we're going to talk about all the way from tin cans to telephones, from sunlight to slow songs. So, the evolution of transmission of waves is really what I'm talking about. Is waves are a way that we can transmit information, and the information that I'm talking to you right now is traveling over waves. If we were in class, when I talk to you, the information would be traveling through waves as well. And so, let's start out with tin can phones. Uh, it says these work purely on mechanical waves, vibrations transmitted through different materials, from vocal cords to air to paper cup to string to paper cup to air to ear. And so you talk into here in a mechanical vibration. It vibrates the cup, it vibrates the string, it vibrates the second cup, it vibrates the air, and it goes to your ears. It's all the transmission of vibrations in waves through the materials to your ears. Those are all mechanical waves. So the next step is to look at something that actually the Navy has these in their ships. They're called voice-powered phones, and they're literally just two of our speaker cups connected together by wires, and there's no electricity needed. Hence the term voice-powered. And so it's almost just like what we have here. It's a little more complex than that. But when you speak into the cup, you vibrate the cup, which has a coil next to a magnet. When you do that, that sound produces electromagnetic waves in the wire due to the interaction between the coil or the electrons in the coil with the magnet itself as they vibrate. That will send vibrating pulses through wires. And if the wires are connected to another cup and they're in a circuit, it will send vibrating waves through the whole circuit. And the fact that this vibrates will cause this one to vibrate, and you can hear it somewhere else in the naval ship. So it says this time the vibrating cup is a transmitter. It vibrates a magnet near a copper coil of wire, which causes the electrons in the wire to vibrate, which sends those as electric waves through the wire to the other cup, which vibrates the other magnet on the receiver cup, which vibrates the air to make it audible. Note, this is voice powered and requires no external energy, no batteries, etc. So this is much like a generator. Your voice is generating electricity, and this is much like a motor. It uses electricity to make motion. So if you have mechanical energy to electricity, you have a generator. And then if you have electricity to mechanical energy, you have a motor. So the speaker is a motor, and the microphone is a generator of electricity. So then we move down to image 3 below, and it is the simplest wireless voice-powered phone. If this could work, you would have, let me get rid of this, it's kind of in my way. You would have remove the wire, and now I've made the wire stand straight up like an antenna. And so since this one is the same exact thing as before, you're speaking to the cup, it's vibrating the wires next to the magnet, it's making electrons vibrate inside the antenna. And anytime you have a vibrating charged particle, that creates electromagnetic waves. So instead of the electromagnetic waves traveling through the wire, they can actually travel through the air. It won't be as direct, it won't be as strong perhaps, but when that electromagnetic wave hits this antenna, it will cause these electrons to vibrate as well. And if the two antennas are tuned into the exact same size for the wavelength that the wave is traveling in, then they will be able to speak to each other more strongly. And these electrons will resonate. And when they resonate, they cause vibrations inside this circuit, which passes by this magnet, which causes this cup to vibrate as well. That vibration will send sound to this person's ears. So that sound on the right hand side will mimic the sound on the left hand side. And I'm not even sure if you can see the mouse moving back and forth. So I am moving the mouse, but maybe I got to go back and get that other part so you can see what I'm talking about. Anyways, since the wire has vibrating charged particles in it, the electrons, it will emit electromagnetic waves. Any vibrating charged particle, i.e. electrons, will emit electromagnetic waves. That's how EM waves are created. These waves will be the same frequency as the sound entering the microphone, the transmitter. EM waves will then travel through space, and when they pass by the receiver antenna, the electrons in the antenna will also vibrate, resonate, particularly if it is tuned to the same frequency by having identical antenna size as the original antenna. Equals receiver. This will cause the receiver to vibrate and make audible sound. So, and we move on. Okay. So this top one is mechanical vibrations only. Let me see if I can bring back that and get some sort of a pointer. That's the mouse pointer. I'm not sure if you're actually seeing that. Anyways, whatever. Okay. So the idea here is that you have this guy's talking. He's making mechanical waves. These mechanical waves are traveling through this wire's mechanical waves and making this vibrate. Okay, so far so good. Here, somebody inside here is on a microphone, and it's making the electrons in the antenna vibrate. And so since electrons in the antenna are vibrating, not the antenna itself, but the electrons in the antenna vibrate, it's causing electromagnetic waves to go out in all directions from the transmitting antenna. This is a radio, the simplest form of a radio. This antenna has a length, and it's these loops of wire, and this length can be changed by this little knob on the bottom, and that will tune it to the correct radio station, 105.1 here, KNZI Country Radio, and that antenna will begin to resonate. And when that antenna, or at least not the antenna, but the electrons in the antenna will begin to resonate. And when they resonate, they'll get stronger and louder, strong enough and loud enough to be able to hear it as the electrons get turned back into sound by the earphone. This actually is a type of phone, sorry, not phone, but a type of radio that doesn't require any external energy. It uses the energy from the radio station to power it. I have an example of one of these in class that actually works. Other students try to make what's called a foxhole radio, which works on the same principle, and I haven't gotten any students to make that work. So if you want to get some extra credit, you can make a foxhole radio. I'll give you some extra credit if it works. Look it up online. Okay, so anyways, the image above is called a crystal radio. Crystal radios work with no incoming energy. Anyways, let's go on and continue on to this last picture, which is the law of conservation of energy with respect to how radios work. So starting off on top, obviously we got the sun. The sun shines down and makes the plants grow. The cow eats the plants. The cow turns into a hamburger magically. That hamburger turns into ATP in a human body. So that human body is going to sing. And so they sing into a microphone. The microphone is just similar as a cup with a coil and a magnet at the bottom. When the cup vibrates, it makes electrons go through this wire. But in this case, we're going to add electricity to the wire to amplify the signal. So the signal is going to be stronger here than just having a cup with a coil and a magnet. We're going to amplify it with the battery. That is going to cause the electrons to move through this wire in waves, which causes electromagnetic waves to travel out through space in all directions. So as it says here, the moving cup moves a coil near a magnet. This causes electrons to vibrate in the wire connected to a radio transmitter antenna. Any vibrating charged particles emit some electromagnetic waves like these radio waves. Electricity is used to amplify the strength of the signal. So as I said, so now these signals are going out here. We've got the tuner. The tuner is going to move the dial to make the size of the antenna match the size of the transmitting antenna. Like AM or FM, it changes the size of the frequency of the amplitude of the waves in order to make it fit the incoming wave. Okay, so this antenna, which is tuned to the size of the desired incoming wave, resonates with it and sends the electrical signal to the speakers where the magnet and coil vibrate a paper cup called a speaker. So now these are resonating and going by this paper cup with a magnetic coil inside, and the speaker emits sound waves, which puts out a sound wave for the listener to hear. For a faint emission of sound, no extra electricity is required. You have to have very sensitive earphones, by the way, in order for that to work. But for loud sounds to be emitted, additional electricity is required for application, like a boombox. Like, for instance, this thing should be plugged into your wall, or it should have batteries. Anyways, that is beginning to end how a radio works. You know, um, the biggest concept is that this is like your generator. You are using your voice to create electricity. The electricity is going to follow through electromagnetic waves to another side. And on the other side, the electricity is going to be turned back into mechanical waves so that you can hear it. And that's the transmission of wave energy. Hopefully that makes a little bit of sense to you.